Good morning guys. In the last class we learned regarding the spherical mirrors. So today we are going to learn more about the spherical mirrors, the terms related to spherical mirrors. So here, as I said in the last class, spherical mirrors are of two types, convex and concave, depending on the outer side, depending on the spherical curved surface, whether it is faced inside or outside. So as you can see certain ray diagrams on the board, here I consider a concave mirror. A concave mirror whose reflecting surface is bent inside. This is a reflecting surface. The shaded part is not a reflecting surface, it is an opaque surface, right? Then, now what we have to do is, we know certain terminologies. So the center of the spherical surface is considered as pole, which is denoted by capital P. Then the center of curvature, it is nothing but a center of a sphere from which the spherical surface is derived from. So that is a center of curvature. And a line passing through the center of curvature and the pole, it is called as principal axis. So this line is a principal axis, right? Then, so let us consider from a source which is at a distance of infinity, we are getting a parallel beams of light. We are getting a parallel beam of light, parallel rays of light, which is parallel to the principal axis. So these are the parallel beam of light which are parallel to the principal axis. When they strike the spherical, that is reflecting surface of a concave mirror, they will reflect back. So here you can see the reflected back, that is the rays which are reflected back, the reflecting rays. So when you observe, see here, all the reflected rays will meet at a point. All the reflected rays met at a point. So that point is denoted by capital letter F, and that point is called as focus. That point is considered as focus. What is focus? All the reflected rays will meet at a point when a parallel beam of light passes through a concave mirror. So that point is called as focus. Then when we consider the length between the focus and the pole, so that length is called as focal length of a spherical mirror. It is called as focal length. The length between the focus. So is this focus what it is nothing but the point where the image is formed. So the distance between the focus and the pole is considered as a focal length, which is denoted by small letter F. Focus is denoted by capital letter F. So this can be understood using a simple activity. In the last class, I had explained you we have to learn regarding certain activities. So what we have to do? We have to take a convex mirror, then go outside, focus a rays of sunlight through the concave mirror and focus it on a piece of a paper. Be careful, don't see the sunlight with your bare eyes. Okay, don't see the light rays which are falling on the concave mirror with your open eyes. Okay, use the sunglasses. It may harm your eyes. So after few minutes, what happened? You can see the paper will burn with the smoke. After few minutes, you can see the paper will ignite. It catches the fire. What all this? What happens is, when a concave lens is focused, okay, when a concave lens is focused via the sun rays, the light rays of a sun, so what happens? All the sun rays will fall and they converge at a particular point on a paper. They converge means they meet at a particular point on a paper. So at that point you can see a bright spot on a paper. At that point you can see a bright spot. So here what happened? The concentration of the sunlight rays, the light rays of a sun increased, which causes a heat in that region, which made that paper to get burned. Okay. So here this image is there, no? The length, this image is nothing but a focus. The distance between the lens and the focus gives you the focal length, average or approximate focal length. So this is how we explain the ray diagram of the concave mirror. Here we have to mainly focus on the two terms, focus and focal length. Then MN, you can see MN. Okay, so this is nothing but a small part of a spherical surface. The radius of a spherical surface, a small part. So this MN is called as aperture. So this is called as aperture of a spherical mirrors. So we learn aperture, we learn focal length, and we learn focus. Okay, so let us see the same light rays when they are passed through the convex mirror, what happens? So this is a ray diagram which is depicting or which is showing the light rays which are falling on the convex mirror. See, convex mirror, here what happens? The reflecting surface is bent outside this side. It is a reflecting surface. Now, the source of light which is at an infinity distance from the spherical mirror, a parallel beam of light will fall on the reflecting surface and we will get the reflecting rays. See, these are the reflecting rays. When you draw imaginary lines through the reflecting rays like this, okay, all the reflecting rays will meet at a point. Behind the spherical mirror. Behind. Here, in front of the spherical mirror, this is behind the reflecting surface of a spherical mirror. So that point where all the reflecting rays are meeting, this is called as focus of a spherical, that is a concave mirror. And the length between the pole and the focus is nothing but a focal length. Okay. See here, the focus point, the image is formed behind the reflecting surface of a convex mirror. But in concave mirror, the focus, the image is formed in front of the reflecting surface of the concave mirror. This is the difference. And aperture, MN is a aperture. Okay. Then, when we consider the aperture of a spherical mirror is very small, so that time we can say that the radius of curvature, what is radius of curvature? The length between the pole and the center of curvature. We discussed this in last class, right? The length between, the distance between the pole and the center of curvature is radius of curvature, which is denoted by capital letter R. Okay. So when the aperture is very small, that time the radius of curvature is found to be twice of focal length. Twice of, that is 2 times of focal length. So this is how the light rays fall on concave mirror and convex mirror, and we will get the focus and focal length. And this is a relation between radius of curvature and the focal length when an aperture is very small. Okay, so today we learned 3 more terminologies related to spherical mirrors. In the next class, we are going to study regarding the image formation by these spherical mirrors. Until that, learn science, observe science, see the science around yourself. I will meet you in the next class by learning image formation by spherical mirrors. Have a nice day.